The universe is vast and mysterious. It continues to expand, revealing countless wonders that challenge our understanding of existence. Since 1929, scientists have discovered a deep connection between us and the cosmos, learning that the very elements in our bodies were created in the fiery cores of ancient stars. By 1957, it became clear that the night sky, while breathtakingly beautiful, is also a powerful reminder of the universe's complexity and strength. Amid this cosmic grandeur, humans often find themselves asking questions about their purpose and the mysteries of planets, stars, and destinies scattered across the skies. Despite all these wonders, people usually stay indifferent to the universe's drama, unless something extraordinary grabs their attention. One such event involves Betelgeuse, one of the biggest and most mysterious stars in the sky. Recently, this enormous red supergiant has shown signs of instability, catching the eyes of scientists and stargazers. Located over 640 light-years away from Earth, Betelgeuse is huge, far larger than our Sun. Its deep red color and massive size have fascinated observers for generations. Even at the speed of light, it would take more than 640 years to reach it. Traveling with current technology would take over 12 million years, longer than human history itself. This shows how immense Betelgeuse truly is. Recently, the star has been trembling and pulsating in ways that raise concerns about its stability. While stars may look calm from Earth, they are anything but. Betelgeuse, known as a pulsating red supergiant, changes its brightness over cycles that can last from 10 to more than 2,000 days. These changes are caused by its expanding and contracting outer layers, signs of its evolving internal structure. Its brightness can change dramatically, such as in February 2021 when it became one of the dimmest stars in the sky. Its surface temperature, about 3,500 Kelvin, is cooler than the Sun's 5,500 Kelvin. Even though it's much larger, this lower temperature makes Betelgeuse look dimmer than expected. As it nears the end of its life, Betelgeuse is going through dramatic internal and external changes. It's running out of hydrogen fuel in its core, which causes the outer layers to expand and the star to grow even larger. Helium then begins to collect around the core, starting a new fusion process called helium envelope burning. In this phase, helium atoms fuse into heavier elements like carbon and oxygen. These reactions release energy, but they're less stable than hydrogen fusion, causing irregular bursts of energy and making the star more unstable. These unstable reactions lead to pulsations in brightness and strong stellar winds, which blow large amounts of mass away from the star. These winds and pulsations constantly reshape Betelgeuse. The expansions and contractions of the star's outer layers, like a cosmic heartbeat, show just how unstable it has become. To study these changes, scientists use tools like photometry to measure light changes and spectroscopy to study light in different wavelengths. These tools help scientists understand what's happening inside Betelgeuse. Astrophysicists also use computer models to simulate how Betelgeuse is behaving. These models use physics equations related to nuclear fusion and fluid motion to predict the star's future. One important process inside Betelgeuse is convection, where energy from the core rises to the surface like boiling water. This movement helps balance the star's energy and causes brightness changes seen from Earth. One of the most fascinating parts of a star's life is the balance between gravity and radiation pressure. Gravity pulls everything inward, trying to collapse the star, while radiation pressure, the energy from fusion, pushes outward. In a stable star, these forces are balanced. But in a star like Betelgeuse, which is nearing the end of its life, this balance becomes unstable. As hydrogen fusion slows down, radiation pressure drops, and gravity starts to pull the star inward. This makes the core heat up, restarting fusion with heavier elements like helium. That produces bursts of energy that push the outer layers outward again. These repeated expansions and contractions cause the brightness of Betelgeuse to rise and fall in cycles. When the star expands, the surface cools, and it looks dimmer. When it contracts, the surface heats up, making it look brighter. These cycles not only look impressive, but also tell scientists a lot about what's happening inside the star. Betelgeuse's massive size and advanced stage make these changes even more dramatic. The core is now mostly helium, and fusion is happening in layers around it. But helium fusion gives off less energy, so radiation pressure becomes weaker and more uneven, leading to the intense pulsations we see. As Betelgeuse moves closer to the end of its life, its pulsations and internal activity are becoming more violent. Eventually, it will run out of nuclear fuel, setting the stage for a supernova, a powerful explosion that will mark the star's end. Until that moment, Betelgeuse will continue to fascinate astronomers. By studying it, scientists gain valuable insight into how massive stars live and die, deepening our understanding of the universe and reminding us of the powerful forces shaping the cosmos.